For everybody, good day. Once again, we are around for today's lesson, and I want to take on a very good example on longitude and latitude. This example will take care of any type of problem that is presented on longitude and latitude. So pay attention to the problem and the solutions. So, what example? Two places P and Q are on the same latitude, 60 degrees north, and on longitudes 30 degrees west and 30 degrees east, respectively. Calculate the shortest distance between P and Q. Solution. There are three distances between P and Q. What are they? 1. The distance between P and Q along the circle of latitude 60 degrees north. 2. The chord PQ joining P and Q. 3. The distance between P and Q along a great circle. I have carefully chosen this example so that you will see that there are actually three distances between any 2 points you choose on the Earth's surface. By the time I draw the diagram, you will see clearly what I am saying. We calculate these distances and then see whether they are the same or there are differences. If there are differences, which one is the shortest? We shall discover the shortest. The taste of the pudding is in the eating. Meanwhile, you have to notice that the chord PQ joining P and Q is like a tunnel through the earth. Is it possible? I leave that to science and technology. But take note that the chord PQ, which joins P and Q, is like a tunnel because it is through the earth. It has to go through the earth. It cannot be on the surface of the earth. It has to go through the earth. Even from the diagram, you will see clearly that it has to go through the earth. If it is possible to dig such a tunnel, it is left to our scientists. So, we are going to look at this problem now. We are going to look at the solution so as to arrive at our answer. So, the diagram shows very clearly all that we are given in the problem. So this is the Earth, the polar axis running through the North Pole, the center of the Earth, to the South Pole. The equator, which of course is latitude 0 degree, latitude 60 degrees north. The point P lies on longitude 30 degrees. Longitude 30 degrees west, and this one is longitude 30 degrees east. The point P lies on longitude 30 degrees west, and the point Q lies on longitude 30 degrees east. Now, you can see how a simpler diagram of latitude 60 degrees north shows you clearly the positions of P and Q, west and east of the prime meridian. This is the prime meridian. The prime meridian is longitude 0 degree. So with reference to the prime meridian, you have longitude 30 degrees west and longitude 30 degrees east. This diagram clearly shows the positions. Now, I want you to see clearly that the diagram clearly shows the three distances. The arc PQ along that circle of latitude, arc PQ. The chord PQ, you can see the straight line PQ, the chord PQ. The arc PQ, you can see the great circle that passes through P and Q, having O as its center. That great circle also gives you its own arc PQ. So you have arc PQ along a great circle. You have arc PQ along a great circle, subtending angle theta degree at the center at O, the center of the earth. Please take note that arc PQ subtends angle theta degree at the center of the earth. That is, by the time you join P to O, Q to O, you have angle POQ. We call it theta degrees. Angle POQ, which is theta degrees, is the angle which this arc PQ or chord PQ subtends at O, the center of the earth. It's very important to get that picture very clear in your mind. So you can see the nature of this diagram. From this diagram, we can go on to calculate these distances. We can get the length of the chord. We can calculate the length of arc PQ along the circle of latitude. We can as well get the length of the arc PQ along a circle of latitude. Please pay attention to this word example, because with it, you can attempt any problem on longitude and latitude. The radius R of the circle of latitude 60 degrees north is given by R is equal to capital R cos 60 degrees, where this capital R is the radius of the earth. That is, small r is equal to 6.00 cos 60 degrees. The arc PQ along the circle of latitude 60 degrees north is given by 60 degrees over 360. Please take note how we got this 60 degrees. It is not because it is latitude 60 degrees, 60 degrees. It is the difference in longitudes between P and Q. Go back and look at the diagram. The smallest, the second sketch, you will see the difference in longitude between P and Q. They are on opposite sides of the prime meridian. So the difference in longitude between the 2 points is 30 plus 30. That's what gives you 60. So please take note, this 60 is not here because of latitude 60 degrees north. No, it's here because this is the angle with that arc PQ subtends at the center of latitude 60 degrees, no, that at the point X. In fact, angle PXQ. Angle PXQ. Go back and look at the diagram. You see angle PXQ. That's what gives you 60 degrees. Over 360 times 2 pi r. Already we have seen that this is the formula we use to calculate the length of arc or the distance between two places on the same circle of latitude and different lines of longitude. The angle which the arc subtends at the center of that latitude over 360 multiplied by 2 pi r, where this r is the radius of that circle of latitude. So by the time we process this to the end, we arrive at 3,352.381 correct to 3 decimal places. We can say 3 decimal places. So this is the distance between P and Q along the circle of latitude 60 degrees north. Let us proceed to calculate the length of the chord PQ. So the second part of that question, we are looking for the length of the chord PQ. Now you can see the diagram I have drawn on the board. That is lifted from the main diagram. You can see the main diagram. You will see this one lifted from that main diagram. So in triangle PMX, of course, is right angled at this point, and PM is equal to QM because R is equal to R. The triangle PQX is an isosceles triangle. Now, in triangle PMX, sine 30 degrees, the sine of this angle is opposite upon hypotenuse, PM over PX, PM over R. Therefore, PM is equal to R multiplied by sine 30 degrees. But we know that R, we have already calculated R to be capital R cos 60 degrees. So we replace this R with capital R cos 60 degrees, sine 30. R is of course 6,400. Cos 60 degrees is 0.25, sine 30 degrees is 0.5. When multiplied out, it gives you 1,600 kilometers. So PQ, which is double PM, PQ is 2 times PM. You can see it clearly here. So it gives you this. So the length of the chord PQ is 3,200 kilometers. You can see clearly that the length of the chord is different from the length of the arc PQ along the circle of latitude. Let us go to the third part now and compare our 3 values for the distances. So we now look at the third part of that problem by considering triangle POQ. So we are continuing with the third part of that problem. If you look at triangle POQ, you can as well see it inside the main sketch. You can see this triangle POQ. It is there, having angle theta at the center of the earth. So that is the triangle I have brought out here now for you to see clearly. POQ. It is inside that main sketch which we drew. So again, it is an isosceles triangle with the radius of the earth as capital R. So in triangle PNO, it is right angled, sine PON is equal to PN over PO, which is 1,600 over 6,400 for R. The radius of the earth is 6,400 kilometers. So that is what we have here. When simplified, it gives you 0.25. That is angle PON is equal to 14.5 degrees. So angle POQ, which is twice angle PON, will give you 14.5 times 2, 29 degrees. So the value of theta The value of theta degree is 29 degrees. Now that we have got the value of that angle, POQ, we can now get the length of the arc that joins PQ along a great circle. Along a great circle, not along the circle of latitude, but along a great circle passing through P and Q. Please take note. The arc PQ joining P and Q along the circle of latitude is different from the length of the arc PQ joining P and Q along a great circle. They are very different. As you have seen in the calculation, they are different. They are not the same thing. And the length of the chord joining PQ, we have got all these values. And very clearly, we end up getting the length of that arc on great circle joining P and Q to be 3,240.635 kilometers. Correct for 3 decimal places. Now, from the values we obtained in the first part, the second part, and the third part, we find one, that the distance between P and Q along circle of latitude 60 degrees north is 3,352 kilometers. This time, correct to 4 significant figures. The length of the chord PQ is equal to 3,200 kilometers. Again, 4 significant figures. And the distance between P and Q along a great circle, that is this arc PQ, is 3,240 kilometers. Correct to 4 significant figures. Very clearly, we can see that these values are different. They are not the same. They are not the same. The length of the arc along the circle of latitude, the length of the chord, the length of the arc along a great circle, the three of them are different. It is now easy for us to see which of these distances is the shortest. We can see for ourselves. Very clearly, you can see that it is the chord that gives you the shortest distance. The shorter one is the distance between P and Q along a great circle. And the longest distance is the one between P and Q along the circle of latitude, as you can clearly see. I hope, yes, that is the longest distance, followed by this one, but the shortest is the chord. But as all of us can see, we are on the Earth's surface. We are not inside the Earth. And so when we are considering distances, we consider distances on the Earth's surface. So if you are looking for the shorter distance on the Earth's surface between P and Q, you can see that it lies on a great circle. That is the shorter distance. But like I told you very clearly, that there are 3 distances. There are 3 of them. The one along the arc, the circle of latitude, the one along a great circle, an arc on a great circle, and the chord. And so, from what we have done now, you can see that they are very different. And it is easy for us to see the shortest distance, the shorter distance, and all that. So I believe you can attempt any problem on longitude and latitude that concerns calculating distance between places on the Earth's surface. I still have something to add to this. By way of summary, you can see that the shorter distance between P and Q on the surface of the Earth is equal to the arc PQ along a great circle. Very important. Whereas the shortest distance between P and Q is equal to the chord PQ. Are you looking for the shorter distance or the shortest distance? Take note again that for P and Q, there are 3 distances to be considered. We have the shortest, we have the shorter, and so on and so forth. So I believe any one of you can attempt any problem on longitude and latitude. May God bless all of us in Jesus' name.